Hello everybody, Earth.Otherwise here to continue our journey through game programming in C++ start to finish by Eric Yazwa. We're finally ready to put some text on the screen. First, we need to get all of our ingredients. We'll need the SDL TrueType font library, which you can download in the link below or from this URL. Or just Google SDL_TTF and that will get you here. We download the development libraries, and then we need to get the an actual TrueType font. I'm getting mine from dafont.com, the TrueType font section. This one works well enough. Get that. And finally, we're going to get the sprite font file from the graphics tutorial part of Ben's old graphics tutorial GitHub. The link is down below, or it's here, or you can go into his videos and he'll also have a link if mine is not working. Remember to read the licensing for each of the third-party items that you take so that you can make sure that you're not going to get hit with a lawsuit if you use it. This is the license right here for the code, and the other stuff will have licensing as well. So what we're going to do is we're going to go into our code. We're going to add a new class. It's going to be called Sprite Font. We're going to copy Ben's code from here. Copy that. Paste it there. And then in here, copy this. And in spritefont.cpp, paste it here. And now we have all the code we need. Now we just need to put the stuff we downloaded from our downloads folder into the correct folders. We just need to extract these. And now we will take this. We'll just take this whole thing, cut it, and we'll put it in our tutorial, and we'll create a new folder called Fonts. And we'll just put it in there. Don't need that anymore. And then in here, we have include and lib. We have SDL_TTF for include, and then we have in here x86. We need this and the DLLs. So we just go to here, in dependencies, in include, I'm going to make a new folder called TTF. And I'm going to put SDL_TTF in it. And then in lib, in both release and debug, we are going to take the library, copy it, and paste it. Now back here, in both debug and release for this, we need to put our DLLs, which is zlib, SDL2, and libFreeType. Paste those so that we can use them when we run. And that is all we need to do in order to get everything ready for our files for this. Now we need to go into our properties and make sure that it's included. In the properties of our engine, we need to go into librarian, go into general, and then in here, we need to add here at the end a semicolon, and then we need to add SDL2_TTF.lib. And then apply that. That's for debug. And now for release, we need to do the same thing. SDL2 underscore ttf.lib, semicolon. Go back to debug, check. We did not add a semicolon at the end of that. You don't have to add a semicolon at the end of the very end one, but it's good practice to do so. So now we need to make sure sprite font is in our domain, not in Benjamin. And Ben does his brackets differently. Now, in here, we don't need vertex, because I don't believe we even have a vertex.h file. Heck, I don't think this needs it at all, actually. But it does need a multi-sprite, so we're going to add that. Did not spell that correctly. Multi-sprite. And down here, we're going to be replacing sprite batch with multi-sprite. And I think color RGBA8 is actually something we have here. Let's just copy that. And oh yes, I'm Canadian, so I put a U in it. Ben did not. So pop into here and change this a little bit so that this is multi-sprite. And this is the correct color, unlike you Americans. And that, then we pop all the way up to the top. Sprite batch is not a thing we have, but multi-sprite is defined in the .h file, so that should be fine. And then here, make sure we're in otherwise. And that should be all we need. Unless spritefont.ttf isn't quite working, which actually I believe it isn't. So if we add from our dependencies, from our include, from ttf, spritefont.ttf, add that. Not sprite bat. Here we are. Yes, SDL is actually in SDL/. Put that there in the two areas that need it, and then way down here at the bottom, there again. And there's lots of things here that tell you how SDL/TTF works. If you want to read through it, which I encourage, please do so. So let's just remove that. There we are. And now, here, we should have no problems. Control-Shift-S to save all of that. Now, in Multisprite, we actually, in here, it uses this batch.draw, which is essentially multisprite batch.draw, but it's not called draw in our thing, it's called add sprite. But our add sprite function does not take these, so we're going to create one. So in multisprite.h, we're going to create a new add sprite, void add sprite, and it is going to take some GLM stuff. So we need to include GLM, include GLM/GLM.hpp, and then here we are. In add sprite, we are going to GLM vec4 dest rect. That will be the rectangle for each of the letters. GLM vec4 UV rect, which is the UV rectangle. It won't just be 0 to 1 because it's a character sheet, which means that it will just be taking little rectangles from within the larger UV there. Then, if we pop in here, we need a texture ID. In this instance, texture ID is an unsigned integer, not a GLU int. So, unsigned int texture ID. And then we have a depth, which is a float, and a tint, which is a color. So, float depth. Is that depth? Yeah, it's called depth. So it's the stuff here is 3-dimensional, and then color RGB 8 color. There we are, and then we add this to the .cpp file, and you see now that this has gone away. So that's all we need to do in sprite font. So now we're going to do a little changeroo here in this, in the .cpp file. We need, here's add sprite. We need to set it up so that these vec4s and stuff are translated into a form that our sprite, or sprite batch and sprite can use. So what we'll be doing is we're going to be translating the desrect, uvrect, texture ID, depth, and color into vertices. We're going to need vertex bottom left, vertex bottom right, vertex top left, and vertex top right. And then we're going to want msprites dot emplace back, and then we're going to emplace texture ID depth bottom left, top left, bottom right, top right. And just to be sure, I'm going to look at a sprite and make sure, yep, might need to change this depth function because it assumes that all of the vertices are going to have the same depth, meaning they're going to be flat in world space. This may not be true for much longer. In fact, I'm almost certain it's not going to be true because here we can very quickly change this to be 3-dimensional. But we'll worry about that in the next one when we actually deal with 3-dimensional things. So, here we're going to define each of these things. And they have to be defined in a very specific order. So, desrect .x for x, and that's going to be true for all of them. Desrect.y. Now, depth is going to... wait, no. We haven't modified it, so we don't actually have to put depth there. I have modified it in the version I'm looking at. And then uvrect.x, uvrect.y, and then color. That should be everything we need. Yes. Okay, so this is the basis for every single one of them, because all of them need this. Because this this determines this is the bottom left corner, and everything is everything's based off that. So bottom right isn't desrect.z, which is the second x coordinate. It's x plus desrect.z. Because .z isn't the second coordinate, it's the width. And then x plus uvrect.z. And then for top, it is y plus desrect.z. dot w, and uvrect plus y plus uvrect. Oop. Accidentally hit some wrong buttons there. Oop. Plus uvrect dot w. And then we bring it all home for top right. I'm not going to show that. Anyways, that is everything we need for this add sprite function. So now that the add sprite function is done correctly, we can close that. We don't need camera. We don't need cameras. We do need to keep these open. So the function, our function that does our sprites, does something weird with them. That means that we have to flip this. So it is vec2 dot x, and then it's vertex uv dot y. It's actually 1.0 minus this. So essentially it will flip them in the y-axis, which it says essentially what we're already doing over here with our PNGs in main. But I'll actually show you what happens if we get rid of that. Though obviously you should test on your own before I even show you. But here, we're going to need to include sprite font.h, and we're going to need to create a sprite font. So right around here, let's do otherwise sprite font, and it takes two parameters. It takes the location of it, so it's in fonts /60/60.ttf, and the other variable is how large it is in pixels, which we're going to do 64. If you put this number large enough, you will get errors because that is the height in pixels of each letter, which means the larger it is, the more crisp the art will be. However, it also means that the sprite sheet gets exponentially larger as you make that number larger. So it can eventually make it so that sprite font can't even create a character sheet for it. Anyways, next we're going to create a char buffer, which is a character array. We're going to put 256 in there because you want you want a array that's at least as large as anything you're going to put in it, because overflowing a buffer like that can have some very bad consequences, like memory leaks and bugs that make no sense whatsoever. Now we're going to fill that with sprintf_s, which is the safer version. We're going to fill our buffer, and we're going to fill it with test string. That's just what I want to fill it with. You can put anything in there. Now we're going to do sprite font.draw, and we're going to pass in a few things. Actually, we also need another otherwise multi-sprite, because if you attempt to write words as in the same multi-sprite as you put an apple, then the apple is going to look like a random part of the character sheet. Now, multi-sprite 3, I believe this one is. And then in the draw function, we're going to pass multi-sprite 3. We're going to pass our buffer. We're going to pass the position, the glm vec2 position, to And I'm going to put this at, something where we can still see it in both 2D and 3D. I'm going to put it at 2.0f, 0.0f. Oh, wait, no, flip that. 2.0f, 0.0f. Because things are kind of weird. Don't worry about it right now. Now, scaling is GLM Vec2. Now, I believe our scaling has to be fairly small so that we can see it in 3D. So I think I'm going to put it to like 0.01f. If you can't see it, we can change that up. Its depth is 0.0f. Its color is otherwise color RGBA8, and then it's just going to be white. 255, 255, 255, 255. And that should be everything. Bit too many brackets there. But yes, now that we've drawn it, we just need to render it. So multi-sprite 3 dot render batches, and we're also going to put it over here in the 2D so that we can see it in both, though we might actually not be able to see it in both due to how 2D and 3D draws differently. And we need to remember to multi-sprite 3 dot prepare batches. Now we just run it and see how it turns out. Made a small mistake here with this percentile being there rather than over here. We don't want to mix that up. This is in the debug properties of Otherwise. Need to check the release as well, make sure, yep, that's on the correct side. We also need to remember to initialize our multi-sprite. Dot init. As you can see, there it is, way down there, super tiny, and it's probably the same right down there. While I was messing around, I changed things a little bit, so let's just go ahead and make this a little bit bigger. 1.1f. Actually, for 3D, this is actually probably way too big to be seen. But we'll see it in the 2D, and then I'll show you how to make it visible in the 3D. And as you can see, it's very visible in the 2D, now that it's behind the apple, but you can see test string. And now, we need to make it incredibly small to make it visible in the 3D. Because if you'll remember, our apple is only one, like it's only one tall, and that is actually 64 tall, meaning it's like we're seeing the very smallest portion of the bottom left corner of it, which is transparent. However, if we make it super small, we should be able to see it overlapping our green apple. And there is our test string, just, very sideways to us because of the position of the camera, but there we have it. So that's everything we needed to do just to render text to the screen. There was probably a much simpler way, but a lot of that stuff will be necessary later. This has been Earth Otherwise. Thank you for watching.